Hello, everyone. Good evening. Welcome to class.
Hi, good evening.
Hi, good evening.
Awesome. Can hear you. All right. Welcome to cybersecurity, or specifically IT security analyst class. All right, guys, let's start. So let me share my board with you. Share screen. All right. All right, guys. So as you may already know, my name is Akin Aregbesola. I'm your trainer for the entire cybersecurity course. The comprehensive training is a 3-month course, but we'll be focusing on the courses one by one, month after month. In this first month, we'll be talking about IT security analyst. All right, so to help us so we don't go too far off curriculum or syllabus, I have the note here ready. All right, please confirm you can see my note. I'm sharing my note.
Yes, we can see it.
Okay. So, this course can actually be termed the role for which you qualify after this training can come in different nomenclature, but generally the popular ones will be IT security analyst and then vulnerability management. And in this course, we are going to look broadly at all of these topics. All right. And then we'll just spend the first half of today to cover the theoretical concept of where we are going so that as much as possible, I have everybody on the same page. And then once we are sure everybody's on the same page and we have the proper foundation to build on, we'll go ahead to start the practicals right away from day one. All right. So in the first 1.5 hours or maybe 2 hours, I just kind of concentrate on helping you understand the concept behind what we'll be doing in the next 1 month or the next 2 months or even the next 3 months. All right. And then I'll be using pictorial diagrams as much as possible, like I'm trying to do here, to explain concepts. All right. So let's start, guys. So in IT security, when we talk about IT security, before we even mention analyst, so what we basically have in mind is that your organization, whether you or your organization you are working for, you are running a software. I mean, this is the scenario we always have in mind every time we talk about IT security. IT is very wide, but security part, we are saying that the organization has an application, has a software that is running. This software could be a software like Uber, Uber application, the taxi app, or Grubhub, or any of the many applications that you already know about. Which one should we use? Since Uber is very popular, maybe we just call it Uber. So your organization is running an application, software, but these days we call software application or simply app. So every time we talk about software, we talk about application, we're talking about the same thing, which means some app that you have developed and placed in the cloud that people, maybe everybody, or maybe specifically organizations for whom you design that app can connect and make use of the app for whatever it is. In the case of Uber, for ordering cabs, or for ordering food, or for ordering delivery, whatever it is. It could be a dating app, it could be an app that hospitals use to manage their patients. there are millions of different kinds of apps. All right, so your organization has this app, and they place this app in a server. All right. And then they make this server available, usually in cloud, but not all the time cloud. They have this app in a server, and then they make this server available so that customers from around the world, their customers, and they run in billions, not just millions, can connect over the internet to this application. All right. So in this case, we call the customers the users. User. Again, may not always be global, could be restricted so that only enterprises like hospitals have access to the application if it's hospital related. Anyway, so this server is now placed in a network. This is the public network, for example, the internet. But this network is not public. This network belongs to your organization. It's a private network, which has the server that runs the application. Okay. And usually when you have an application, there's the back end of the application where the programs that run the application reside. To differentiate between this server and this server, we call this server that the public, your customers, the users, first interact with on your network. We call this server, this first one that hosts your application. We call it the front-end server or the web server. This other one, we call this one the back-end server or the application server. And then there is always a database that houses all of the, in the case of Uber, all of the data of drivers, of customers, what cars they own, where they reside, and where they operate, all kinds of details. So you can imagine there will be billions and trillions of data that Uber is maintaining in order to be able to implement this application. So together, so when you connect with Uber, the website of Uber, for example, the website will connect with the back end and say, we want this kind of information. The back end or the application server will connect with the database. It will fetch the information from the database, and then the back end or application server will give the information to the front end, and then the front end will now give the information to you that is browsing the information through maybe your laptop or maybe your mobile phone. In which case, we call this mobile phone your end point. Honor. All right, so do you see what is involved now? That at the heart of all of this IT infrastructure, we have your data, otherwise called database. We have your back-end server, otherwise called application server. We have your front-end server, otherwise called web server. We have your entrance to the network, your private network, otherwise called, I've not told you what that one is called. And then we have the public internet, and then we have the user. Therefore, there are different layers of this system that needs protection. If they are not protected, it means that even though there are only 500,000 subscribers to this application, then the whole world, the whole 8 billion people of the world can just attempt to connect to your application at once. Is that what you want? No. All right. It could be a bank application. It means that people who do not even have access, who do not even have accounts, or are not even registered with this Bank of America, for example, would be able to log in and have access to the network of Bank of America. And then once they have access, it's just like allowing some stranger into your house. You think that if some stranger just come into your house, they might not cause havoc or cause harm. All right. So just like you have your home, and then you put a gate at the door, and then to every room you put a door just to ensure security. So exactly is this network. All right. These are the properties you have in the house. So at the entrance of your house, you want to put a door so that whoever is coming in will be checked. First of all, they knock, and then who are you? What are you looking for? Oh, it's you. Okay, come in. So that kind of scenario is called authentication. We'll talk about it. Let me not introduce heavy words. And so on and so forth. So this is where you come in as a security person. So what do we need to secure in this scenario? At the core of everything we are securing is this guy, the data. The most important of them all. So what are you securing? You are securing servers. All right. What else are you securing? You are securing the applications running inside this server. What else are you securing? You are securing the entire network. What else are you securing? You are securing even the user to ensure that their identity is safe and secure. In other words, user one, when he says he's user one trying to log in, your regular customer, is actually user one, not some user two pretending or impersonating user one. So there is need for authentic security at the user level. What about even the network through which they connect? So you see that security now, when we talk about IT security, it spans across one. Okay. Okay. So there is user security. There is endpoint security. There is network security. There is application security. There is data security. So these are the different layers or levels of security that we have just tried to highlight here. All right. How many of them? 1, 2, 3, 4, 5. So we call these different layers of security as exemplified here, the domains, security domains. All right. Ultimately, you will be specializing in one of these. But as a beginner, we want to take an overview of what it is to say we are doing user security, we are doing endpoint security, we are doing network security, application security, data security. And then when we now bring the word security analyst, it means that we're able to look at the security features around our data, and we're able to analyze it and determine, yes, this database or the server that the database runs is secure or not secure. What are the second and fourth type of security? Fourth domain of security. Endpoint. We'll still talk about it. Endpoint. And then the fourth is application. If I ask you, what are the different domains of security? We'll add more later, but for now, this is what I expect you to mention. All right. And then if you say you're a cybersecurity person or you say you're a cloud security person, I may want to dig further and say, okay, oh, that's interesting. Which or which of these domains do you specialize in? And then you can tell me, I'm a network security guy. I'm a user, otherwise called IAM, and so on and so forth. I'm sorry, I don't mean to confuse you. Let's just be consistent. All right, so back to this. As an analyst, you are going to analyze the security features around your database and tell me, based on my analysis, based on the tool that I have used to check this thing is secure, and therefore it is unlikely, in quotes, let's use that mildly, that unauthorized users will be able to access your database. And then I say, okay, what about my application server? And then you run some tools that we are going to learn in the course of this course. And then you come and say, based on my analysis of this server, there are certain weaknesses around the server that if we do not, those weaknesses is what we call vulnerability. I'm actually careful not to mention those words because you guys warn me that you are completely new to IT. So as much as possible, I'll be introducing those vocabularies gradually. Let me just speak normal English for me. Anyway, so once you're able to identify 2, 3, 4, 5 weaknesses around this as a result of your analysis, then I say you are a security analyst. You analyze my server and tell me that based on this, just like a doctor, and then based on what I see, based on your temperature, based on this test, I can maybe not conclude, but it is likely that you have a fever. And so it is with this to say, okay, based on this, it is likely that these ports and these areas are weak. Therefore, you may want to take this prescription, do this, in order to further fortify this area and make them strong and hard for attackers, at least you should know the meaning of that, attackers or illegal entry to happen within this server. What about the network? Of course. In fact, this is the parameter of your home that you want to protect, that you want to use to protect your home as much as possible. Once they are able to get into your home, then it is likely that they can cause damage. But as much as possible, you want to keep them off your home. In the case of IT, your home is your network. You want to keep them off. All right. So of all of the security, this is the primary one you really want to protect. So if you're able to now come here, you understand networking enough to know what to look for and then to know what to analyze and to be able to come to the conclusion that this network is safe or this network is not very secure based on this, then you are a security analyst at the level of network. And like we said, even at the level of application and data, you do all of that. So in the course of this 1 month training, you will be able to use different tools, different security tools. It is because of these tools that we're often calling these people engineers. It's not like they're using screwdriver or any engineering tool. The tools they are using are the different software that we are going to be learning to use. You learn to look at the users, look at endpoints, basically servers, and not just servers, also the devices from which the user is logging in, your network, your application, and your data. That's what we aim at. But before we ultimately get to the point where we begin to use the tools to do the analysis, otherwise called the vulnerability scanning of these devices and services, we need to learn how users work. How are users created? How are passwords created? How do networks work? What is an application? How do you put a network on how do you put a server in an application? We need to be familiar with all of that before we can now say we understand this concept enough to be able to analyze it. So for that reason, we are going to set up our own network where we'll practice all of this. To set up our network, okay, before I take this off, any question? Please feel very free. This is just the first class. So we can afford to take even, pardon me to use the word, stupid questions if you feel that is it. That's what it is.
I have
So
a
feel free.
question.
Yeah, please go on.
I have a question. Can y'all hear me?
Yes, we can hear you. Can you hear me? We can hear
Okay.
you. Go on with your question.
Um, so I'm taking notes, but I see that you're like, creating a vision for us, which is really great. So I'm just wondering, Do we need to be, trying to take notes as much as possible, or will this be provided in a different way? Or I just want to make sure that I'm.
Yeah, you're taking notes is great. Take notes, but I do have a comprehensive manual,
Okay.
86-page manual for you, if you can see it here,
Okay, cool.
where I've explained the meaning of all of these terms that we are using. So your notes should just be basic because the comprehensive one is already contained here.
Okay.
Yeah.
That's all I wanted to know. Thank you.
Good. Questions, please. Yes.
So quick question. I just want to know, I know you ultimately you gave us the notes or the handouts, but will we get maybe like access to the recording to just
Yes.
okay.
Yes. As we are talking now, even your own voice, your question is also being recorded now. So you have access to it, just undiluted, unedited, exactly as it is.
Okay. Because
And
sometimes you might be making important points that might not necessarily be captured in the notes. So I
yeah,
have to listen. Okay, thank you.
yeah, definitely, yeah. The approach of the note is formal, but in class we ask questions, we repeat stuff, so definitely you need the recordings. And then ultimately, the projects that we complete in class together, you need to watch the video all over, and understand it, and then look at the note and be able to copy and paste commands to execute the same project. And then you get results. It's working, it's working. It's only at the point of, oh, I got it, it worked, that you are now qualified to put it in your resume to say, I did. Cool. So no need to know. Yeah, just take notes sparingly because we have the detailed note for you. Yes.
I have a question.
Yes, let's go.
Okay, so to my understanding, this is cybersecurity. Is this going to be able, once we complete this course, is it going to be able to cover the same thing as I know Microsoft has their own side of it. Is it the same or is it different?
It's different.
Okay.
It's different. So good question. Let me explain that part. So okay, so Control N. Okay. So in this cybersecurity, or this specifically, because cybersecurity is actually, if you ask me, it's not really a term, it's just a marketing word. It's really, really wide. It covers almost everything IT. So specifically, I want to call this IT security analyst. So what we're going to do here is, on our laptop or on our system, we may not all be using laptop. We have our system. In my own case, laptop. So I'll call that my laptop host. You understand now why we call it host in a while. So my host is running an operating system. In my own case, I'm running the operating system Windows 11 on my laptop. So on my laptop, which is the host, I'm running Windows 11. Yours could be Windows 10 or something. All right. So what we are going to do now, shortly, is that we are going to install a software generally called Hypervisor. Hypervisor, what does it do? What's the meaning of software? We have a laptop that is running Windows 10 or Windows 11, and then we are going to download some software. That's the first tool we'll download and install, generally called Hypervisor. But specifically, the type of hypervisor we'll be downloading and installing is Oracle Virtual Box. There are many types of hypervisor. So what this does is that it creates an environment that now allows us to create as many other laptops inside this laptop as our resources can carry. Let's assume, for example, 5 laptops. But these 5 laptops, they are not physical laptops. They are only imaginary. They are virtual. So we're going to call this virtual machine. Virtual machine 2, virtual machine 3, virtual machine 4. All right. So on this virtual machine, we are going to load Windows Server, Windows Client, and then we are going to network them all together. All right. So that they now provide the controlled environment that we described earlier on, where we now have this network, where we are imagining our application is running. So because we have this virtual machine, virtual, it's not real, we call them virtual, and the machine that is hosting these visitors, this visitor 1, visitor 2, visitor, this is the guy. So that's why we call this one host. Host of these machines, these virtual machines. So that's what we are going to create. And this is to form our lab where we are going to be doing all of our cybersecurity analysis, penetration testing, trying to hack a system. Otherwise, it is not legal. It is not ethical for us to try to attack or to hack into somebody else's system. It's just like you are going into somebody's house, and because you want to test the strength of the wall to see whether it is secure or not, you are attacking the wall. That's illegal. That's not allowed. So because it is not allowed for you to hack other people's system, you create your own system and use it to learn your security and the security analysis that we mentioned earlier. All of this is happening within your own controlled environment. All right. But at some point, you are going to replicate all of this in cloud. You move this month 1, the first month of training. By month 2, when you would have covered all of this, then you now move into cloud, and then you go into Azure Cloud and create virtual machines and be able to do all of these things at the cloud level. So at the cloud level, you are going to essentially repeat everything you already know here and then do much more than that. So this is the one we called Azure Security Engineering, the one where you do all of that in cloud and many more. And this one where you don't go to cloud yet, you are doing them within your own created lab and your controlled environment. We call this one IT Security Analyst. So the person who asked that question, that's the difference. So IT security analysis is the foundation, the fundamental of the real security in cloud. If you understand these basics and you know what we're talking about, then we'll become confident to take you into cloud now to learn the mature one. So at this level, we are looking at the jobs of about 60K to 80K, and then thereabout. I mean, not so rigid. But at the level of being able to do this and many more in cloud, you'll be looking at definitely 6-figure job, usually 120 to 150 or thereabout. Or let's be modest, let's just say 100K and above. All right. So it is at this level that we are looking for roles. Anyway, we'll look at the roles because we have a sample resume ready made. So when we get there, we are going to show you what roles, and then we're going to LinkedIn, we're going to Indeed, and we'll look at what you have covered and what we would have covered there. And then we'll see, based on the fact that you know to do this, you know to do this already practically, of course, you will see for yourself that, oh, I qualify for this role, I'm going to apply for that role. But this is low entry compared to if you go to month 2 and you learn the more technical one, which is more universal, more versatile, and therefore a higher entry level, a higher, when I say entry level, entry barrier than this other one. All right, so did I answer that question?
Yes, thank you.
Yeah.
All right. So our courses at the beginning, in the first 2 weeks, we are going to be really, really busy doing practicals, a lot of practicals, because we are going to be setting up Windows, no, not there. We are going to be setting up our hypervisor. We are going to setting up our virtual machine. You are going to run into problems, and then you are going to be posting, I cannot do this, I cannot do that, and then we'll support you to do them all. That way you can claim one major experience. And then once you leave class, now you can begin to go and look for that. The experience you are taking away from the first 2 weeks of training is that you'll be able to, one, understand the concept of virtualization and be able to create an enterprise network of, in fact, that's too big. Let's just keep it simple. You are going to create Windows server network. And then you are going to be able to manage. But in technical terms, the word manage is replaced by the word administer. So you're going to be administrator for a domain network. So within the first 2 weeks, you already qualify for this role, because we are going to cover TCP/IP configuration of a virtual system. To have a network, you are going to have trouble pinging this network from that one, and then ultimately you're able to join. Yeah. And then after that, once we get the network working, it's working now, we'll now start to do our testing around creating user accounts. What are the different processes or steps that we can implement to make sure that the user account we create is safe? And occasionally, when we feel that it is not safe, what can we do to remediate those situations? What about the server we create? What are the different procedures that we can take to harden? That is the word. Harden means to further secure, to harden the security around the server so that it becomes really, really difficult for people that are not authorized to come in. What about your network? As we explained earlier on. So your ability to do all of your network hardening, server hardening, application hardening, user hardening around here is what now makes you a security, not just a security analyst who is able to analyze and tell you what the issue is. That is called whiteboard security person. You'd also be a keyboard security person, which means you know the problem and you are actually able to go there and click something to rectify the problem. All right, and then we'll go into the second. All right, so back to first month of training. So let's take it step by step. What am I saying with this diagram here? Let me explain what I mean by that. So let me come back here, and then let me open a new sheet. Okay. So what I'm saying there is that there is one aspect of cybersecurity. Of course, you would have heard of that aspect of cybersecurity that is used to be the most popular, except now that I, amongst a few, have said that is not the only part of cybersecurity. There are also this other part. So it's called governance, all right? Risk and compliance. So that is one aspect of cybersecurity. And then there is this other technical aspect of cybersecurity that is operational. All right. And then there is even another aspect of cybersecurity. All right. So what we are saying here is when the organization decides, yes, we want to form a company. We want to form a company that will create an application called Uber, and then we'll do this, we'll do this. So this is where they are. This is the operations. All right. So the original person, the CEO, maybe the Bill Gates of that company or the Elon Musk of that company, will liaise with the regulators if one exists. Or let's come to maybe some hospital software that helps manage patient and keep patient record, patient data safe. So you go to the regulatory body, and then you go to government, get the appropriate license, get the appropriate framework for regulation, and then the governance, risk, and compliance will set up governance, risk, compliance, the policies, all right? And then the risk will look at what are the devices, the services, the applications that will need to be able to meet the business objective. What's our business objective? To create an application that would connect all hospitals in the US and help them manage their patient database centrally. So the business objective. So the governance will stipulate the policies, the frameworks, the management policies, hire the appropriate people that would ensure that the business objective is met. So whatever they have decided here is documented, and that is what drives the operations here. The risk is the part of governance, risk, and compliance that looks at what if some earthquake happens and this operation is taken off service. What do we do to return the business, to return services and be back to business? What if a particular server in operation goes down? So they would evaluate the risk for each of the services, each of the IT infrastructure, and then come up with mitigations as to if something happens, this is what we do to reduce the possibility of that happening in the first place. And when it does happen, or yes, ultimately it always happens, could take several years. This is what we do to recover. That is risk. And then compliance is the part that says, according to the law and regulation that governs how hospitals operate in America, HIPAA, you must have 3 servers, not 1. Every server must be this. You must report incident that you are not able to correct within 24 hours. So these are the regulations. Even the US law says this. US law. So we stipulate all of that. But how do we know that people in operations are working according to the laws here? We carry out auditing, and then we carry out control. So auditing, cybersecurity auditors, control manager, risk manager, they are all part of cybersecurity, but not the operational part. But you now, as analyst, as a Azure IAM engineer, and ultimately as a cloud engineer, you are the person who actually belongs here in operation, working with developers, working with operators, working with other IT people to ensure that everything that has been stated here is actually being implemented practically. So when they said here, there must be 3 servers running at all times, the one active one and the other 2 acting as redundant server, so that in the case of one going down, another one is able to stand in, and the hospitals will not even notice that we lost the server. The person that will implement that here in compliance to this is the cybersecurity operations guy. That's where you will come in when you learn. I mean, the people on the operations side of things. And where are you here? Where are you on this map? Look at it, cybersecurity operations. All right. So the human resources people are here. Can you see identity and access management? That's where you belong. Application security. Remember we mentioned it? That's where you belong. All right. You may not understand everything here yet. All right. But at least you recognize those 2. You recognize, let's go up a little. Payment system, cybersecurity event management. All right. That's where you belong. Cybersecurity incident management, threat and risk management, vulnerability management, which is the core thing we are learning here, vulnerability management. So you belong in the class of cybersecurity professionals that they don't just write paper and write policies that will govern how we do things in operation. They are actually the ones that do the things in operation. So that's why we are setting up a practical environment. If we were here, we'll just be talking policies, talking theory, and writing policy. It will be writing. So I have some trainees who have been doing this, and they say it's boring. I need to do something more practical. All right. And then they come to learn this so that they can be more practical. All right. So that is the aspect. So we'll just do an overview of this as part of the course. Governance, risk, and compliance. We'll just cover it in less than 2 hours, but our whole focus will be on what do we do to ensure that we are meeting the governance, risk, and compliance framework policies, and then the business is running smoothly as it relates to the policies that are set here. Right? So you may want to call this the managerial department, and then you may want, no, outside the HR, managerial as it relates to security, cybersecurity, and then you want to call this one operations. Already have that. And then, of course, you also have contractors who are not necessarily repeating what we are doing, what they have done here or this, but they also have their own services that you can integrate to your operations and even to your GRC to ensure that everything is working fine. For example, one of the jobs of GRC is auditing. You may decide to contract auditing out. Auditing simply means the regulations set here, are they being kept here in operation? So you want to go to operations occasionally and say, show me how you are entering your password. Show me how you are securing your application. And then I'll say, the regulation here says your application must be secured so that all ports to the application are blocked. Only port 443 is open for the application to be accessed. How come you have port 443 open, you have port 80 open, you have port 22 open? You are not meeting the regulation. You are not in compliance with regulation. That's the work of audit. And then they'll write a report to say you are not in compliance. And then maybe another department will now come and remediate. Remediate means fix the identified issue, rectify these problems that were identified. Only this port should be open, this one should be closed, this one should be closed. So the click of button or the command that you put in, and then you check again, you audit again, you say, oh, the issue has been rectified. That is called remedy. You remedy the situation. So it came from the word remediate. All right, so that is where we have this diagram telling you that GRC is not the only arm of cybersecurity. Cybersecurity is much wider than GRC. And thank God you know, and that is why you are here. You'd have thought everything around cybersecurity is just around governance, risk, and compliance. No. All right, did you understand that? Questions?
I think that's really amazing, to open our eyes to all those different, areas and departments and, areas to maybe grow more into or learn about, and just to show us that it's really a wide, area for cybersecurity. So I think that was amazing, because I did think it was just more governance. So just to see it in all those different areas, I think that's really great for all of us.
Yeah. All right, Isaiah, right?
Yes.
All right, thank you, Isaiah. But is that, I mean, everybody following? Like I said, at this level, we just want to make sure everybody's following. We're not going to be, just ask questions just to make sure we're on the same page.
Yeah, well, I'm following.
Okay. Okay. All right. Okay, Brooke is following us. Well, that's good. All right, let's take the next step now.
Question.
All right, I'm happy to take questions.
Oh, just asking. So, is it fair enough to say to at least kind of like back up whatever we're doing right now? It's good to have like the Security Plus certification, like kind of gives you a good backing, because I'm seeing you more on the network side of it than security.
Yes, so everything we'll be doing in this course would help you, will cover enough. In fact, as a matter of fact, we are using the Security Plus certification syllabus to teach you this. So yes, not before you complete this course, but after you complete this course, you would have covered all of the practicals you need and then understood all of the concepts that you need to grasp to be able to pass the Security Plus certification. Yes. Not a prerequisite, if I understood your question, but this course is actually the course itself that teaches you cybersecurity. So all of these are courses. They are topics under cybersecurity. And like you observed, we'll be talking about networking as well. And then by the time we are done with networking, if you had attempted cybersecurity on your, security plus on your own before, and then you go back, it will make more sense because you now gain the understanding of the concept. Yes.
Hi, hi everyone. By the way. I have a question. So this, I know this is like a lot of information. Will we have access to these slides or this
Yes.
syllabus? Okay.
Yeah, this is your manual. This manual I'm showing you right now is yours. So yes, you have access. Then you have access to the recordings. You have access to additional materials that will help you grasp it.
Thank you.
Yeah. All right. So let's go. So
One more question. I'm sorry.
okay.
And I am a person who is new to IT. Do you feel like new students are able to grasp the information pretty good?
Yeah, exactly what I should be asking you. So far, are you grasping what you are saying so far? Does it make sense so far?
Yes, I am, because I've been like kind of studying on my own. So I do recognize a lot of this information.
Okay. So if yes, then yes.
Okay.
Yeah, because we're in class now, so it's not a matter of you seeing if you, not everybody in class has paid. So the idea is for some people, then they just have a feel of, oh, is this whole thing jargon? Is this something I can understand? If yes, they are going to go ahead. But if they feel that, man, I don't understand the word you are saying, and they are too shy to ask questions, then maybe it's not for them.
Okay, thank you. I'm not shy.
Yeah, I can tell. All right. So let's go a bit deeper. So Control N. Okay. So what we explained earlier on, let us explain that a little differently. So we said, okay, at this level, I need, if you can help us make it interactive, I really appreciate it. But if you cannot, I can manage. So at the core of our IT infrastructure, by the way, when I say IT infrastructure, let me tell you what I mean by it. Don't worry, I'll tell you later. But bear with me. At the core of everything we are protecting in IT, what is the core of it? You may not know now, but we'll do it later. We'll still talk about it. I already mentioned briefly, it's
Data.
Data, yeah. And that data is closely related. And we'll put that sign. So that data is closely tied. In fact, to be honest, it is part of your application. But for this purpose, let us just separate it. Application. So your data and application, they run where? They run inside.
Server.
Oh, wow. Some people are already experts. All right. So maybe that one on its server, maybe that one on its own server. Yeah, you could, however you want it. All right. If you want, you can divide the application into two parts, the front end and the back end, otherwise called the web app and the web server and the app server. Okay. So, and then the server runs where?
That should be network.
Thank you. All right. And then your fence that you build around the network, that fence that you build around your network, so that whoever is coming into your network will hit the fence, and then they'll be forced to come and pass through the gate to enter your house. That fence is generally called firewall around your network. Firewall. Oh, it's a wall, but just add the word fire to it. So that's the wall, the fence around your network that we call firewall. We'll be talking a lot about firewall later. And then you now deliberately leave one door open so that all of this area is hardened and fortified. Nobody's able to come through there unless they come in through the gate. And this gate is generally called gateway. All right. So what am I bringing from here? I am saying that we'll be learning about firewalls and network security, server security, data security, application security, right? So this is another way of representing what we drew earlier on. Right? So for this reason, we'll be starting the practical soon, where we'll need to set up a network and then put servers inside. We may not be able to do full-blown application outside of cloud. We're going to do that in cloud. But for now, let us just, like many of you keep saying, you are completely new to IT. Let's even start from creating and understanding a typical network outside of cloud before we now go into cloud. All right, just to add a little to this. So in operations, what happens is that what happens in operation is I'll not be able to represent well what I want to represent. Let me draw this in a different way. Let me draw this in a different way. Let me draw it like this. So we have the typical user of our application, where one user represents 100 users. And then this user connects to some mobile device or some device anyway, maybe mobile or static device like laptop. Or we have user, we have a endpoint. Then through the endpoint, they connect to the network, and through the network, they connect to your enterprise. You are working for Yahoo. This is Yahoo's network, all right? And then your data, Yahoo's data is there, and then they have that, all right? Where these two together is your application, and this one is your data. And this is your network. So these are the 5 domains of IT security. So imagine that you have 1 million users connecting to Yahoo, all right? And then they are connecting from 1 million different endpoints through the public internet. And then there is always the entrance door to your network. And this is where you put this is where you secure the network security. Okay, that is one area you stay to secure the entire network. And then, of course, you also have granular level security at that level, and then at this level. All right, so when you're discussing with yourself and say, okay, I'm a cybersecurity guy, oh, great. I'm a cloud security, oh, great. What's your domain of specialization? And then one person says network, ah, wow. Oh, I specialize in data security. Another person says, oh, I'm an application security professional. This is what they mean. Anyway, so now, if you imagine that there are many endpoints, then it becomes difficult. You may not really get it now, but let me go ahead and just say. It becomes difficult to manage thousands of endpoints to secure thousands of endpoints discretely. So what you want to do, what's typically done is that all of the monitoring here, all of the logs, that's what they are called. Since I'm mentioning that word for the first time, log, which is basically about activities going on as far as users using the application, coming into your server, going out of your server, all of the logs from this network, all right? They all have logs. So you can centrally aggregate, collate all of those logs into a central single place where you can see all of the logs of the entire network. That is huge even for companies that have thousands of subscribers, not to talk of millions of subscribers. So this singular place from where you can monitor and detect any anomaly, whether that anomaly is around user, is around the endpoint, which is the device they are using, is some country network try to hack into your private network, if they successfully hacked into your web server, whatever it is, everything can be seen here. Of course, the screen is too small to capture everything. So it now relies on you being able to click what you want to see, what you want to monitor, to know what to display here. So this system that allows all this monitoring, as we just explained, it is called Security Information and Event Manager, SIEM. And when you do detect, the word is detect, not discover. When you detect any anomaly, then this is tied to another system where you take action to say, based on the fact that I detected some suspicious user trying to access our application, block that user, terminate the session of that user. You take action based on what you detect. All right? We call that response. All right? And that response unit is called security orchestration, security orchestration, automation, and response. So, all right? So altogether we have 1, 2, 3, 4, 5, 6, 7 domains of IT security. These are the 7 domains we'll be looking at. Elementarily, in the first 1 month, using the limited resources that our simulated, our controlled environment can provide us, Windows Server operating system, and the domain controller services. And then ultimately, when we get into Azure, that is where we are going to have this experience. And then we'll be able to put in our resume, I'm able to create and manage user accounts for my organization, and I'm able to protect endpoint by doing this. I'm able to use IP address to block traffic and to determine who is able to enter our network. I know what to do to work with application developers in order to create an environment into which they launch the application and the application is secure. I'm able to create and man and secure. The word is always security. Database. I know 1 or 2 applications, tools that can help me detect anomalies and rectify them. For example, Splunk, or if we are going higher, Microsoft Defender. I know. So it is when you know all of this, you know how to do. You are now looking for a job as Azure security engineer. And this is the level where I said entry level is usually around 120, 122, thereabout. Again, could be lower, but it's just up. And then, of course, there is room for growth, because whatever it is that you can do in cloud and not just some limited environment, it means that you can keep learning on what you know here until you become some expert in a particular area. And then there's just no room, no limit to what you can attain with that. All right, but for now, I need you to understand that these are the different domains of IT security, and that will be covering all of this, starting with this one. Any question? All right, so that is what I represented here, maybe in a slightly different format, but I just talked about detection, to respond, to detect, to respond, to protect. When I say secure your infrastructure, this is you are protected. All right, time for practicals, guys. So the first month we are going to cover, this is 2 months training. Yeah, ideally it's a 2 months training. So in the first month we cover the cybersecurity part, which I said I prefer to call the IT security analyst. And then the second part will cover the more mature part, which is where you really consider yourself a security specialist, Azure IAM. You can take a look after class to see roles that are Azure. In fact, let me correct this. Right, question? Sounds good. Okay, questions, please. Let me call this IT security. And then we went beyond Azure IAM engineering to cover the whole Azure security engineer, where Azure IAM is just the first 2 weeks of Azure security. But on top of Azure IAM, we're now going all the way to security because we are training to be able to fit into job opportunities out there. So if this is what employers are looking for, then we need to broaden our curriculum to include exactly that. So that's what we call it. However, covering this, 20 to 30% of this is Azure IAM engineering. Means that as an Azure security engineer, you also are already Azure IAM engineer. All right, so the first month, set up our virtual enterprise network on our local machine. And then we're going to learn to administer the domain of the Windows enterprise network that we set up. And then we are going to configure domain security policies for access control. This is where security starts. When you begin to configure security policy, yes, you know that, yes, you have started your job as a security expert. And then we are going to do vulnerability management using tools, specifically using the tool called Tenable Nexus. And then we are going to do vulnerability analysis. We are going to do blah, 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 and so on and so forth. All right. So when we say information security, we're talking about all things information. All right? All things information. Whether they are physical, mental, in your head, not yet written out, in software form, in hardware form, in the form of building, in the form of paper, they are all information related to the job. Related, when we just talked about operations and all of the policies that are set to guide operations on what to do, how to do it in order to meet the business objective, everything there, even the ones that are not written down, is about information. So when you are securing all of that, that is information security. So within information security, you may want to single out the part that is related to IT. We will talk about IT security. So when we filter the IT part of information, then we are restricted to computer hardware, software, and data. Everything we have been drawing earlier on, they are specific to IT. So when we master all of that, we talk about IT security. When we talk about cyber security, then we're talking about the IT security, our IT infrastructure that is exposed to the internet. Not all of our servers are necessarily exposed to the internet. Not all of our IT infrastructure are necessarily exposed. Some are just storage that we keep as backup. They are not on the internet. Nobody can access them because they are not on the internet. So that is not cyber security protected, but it is IT security. Our IT security team protects those ones, even though they are not part of the cyber world. But once they are exposed to the internet, they are become accessible over the internet, then we are talking about IT security. Again, not every part of our cyber security is in cloud. We could have servers that is on-prem within our bank environment, for example, not necessarily in cloud, but it's part of the internet. So our database server may not be in cloud, it could be resident in our head office. So it's part of cyber security, but not cloud security. So we're not talking about infrastructure, part of the cyber security that's in cloud, then we're talking about cloud security. So now you see that this is how they relate to one another. So cloud security is specific, cyber security is all things as far as they can be accessed through the internet, and then IT security is all things whether they are accessible through the internet or not, as long as they are IT related. The goal, now that we know what we are protecting from all of these diagrams that we have drawn multiple times, so the goal of this protection is that we want to maintain what we call CIA. We want to maintain the confidentiality, integrity, availability. So at all times, as the cybersecurity, IT security, or even cloud security professional of this organization, you want to ensure that the confidentiality of data, the integrity. Yes, we can see data, we can see system, is the same thing. If we see the confidentiality of your entire system, you are right. If we say data, we know that all of this, the user, the endpoint, the network, everything is about the data, you are still right. All right. So you want to maintain these three, the CIA. All right. So we'll talk more about what this means. But basically, we are saying, let's look at the note. So by confidentiality, okay. So let's look at the note so we don't jump in. Security control types. We have physical security. So as we have cyber security, we also have the physical protection by security guards, protecting the physical access and the physical infrastructure. In this case of your data center, this is not like, even when you are working from home, the real office that you are working from home for is some real office somewhere, some physical office. So they have their own physical protection as well. All right, so we have organizational security. So hiring the right people, going through the right process, and using the right technology is part of organizational security. We have technical security. This is where you fall in. This is your place. Control, bold. So we are training you to handle technical security, to be able to configure firewall, to be able to configure network access control, to be able to control user access, create infrastructure in cloud, and give role-based access control depending on who the organization and all of that. This is your place. All right. Organizational will be management. Physical, what already said. Then administrative security will be, it's also management related, but these are security that are implemented via strategies, via policies, via standards. So now that we mentioned strategies, policies, and standards, how does that sound? Who do you think is responsible for administrative security? GRC. All right. So they're in charge of drawing the policies and then coming up with standards, procedures. I mean, standards and strategies from which the operations now derive. Don't worry, we'll still do all of that. Let me not. We'll still do the difference between policies and standards. All right, so all of these are built to ensure that we meet the CIA triad of confidentiality, integrity, and availability. This is our foundation on which we do our security. We want to ensure that our data has confidentiality, has integrity, and is always available. Yes. Well, okay, somebody answered the question. Okay, thank you. Okay, I did to come. All right, so levels of application of this control. These are elementary. So we have preventive level, preventive control, we have detective control, we have recovery control, we have deterrent control, we have compensating control. All right, they are things you can read up yourself. Whatever we do to prevent a particular data breach or anomaly from happening is preventive. All right, we'll do all of, okay. In the non-cyber world, you could do at the administrative, organizational level, drug test. to say, okay, we are just making sure that we are employing the right people that will not cause some, and then we can do IP firewall. Yeah, we'll talk more about that. Okay. Okay. A cybersecurity professional working on IT projects must ensure he enforces the security triad of CIA for that project. That is always the goal. You want to enforce confidentiality, integrity, and availability. Since all of our discussions and the entire training will be around this CIA, we'll have plenty of time to understand. All right, cybersecurity architect thinks whiteboard. Whiteboard, how, where can systems fail, then prevent it, all right? But the people who actually do the work of preventing it, who actually do the implementation and key in the thing or click the button to prevent it, they are called the keyboard professionals. Must first understand how the system works to understand where it can fail. And that is exactly what we are trying to do. To set up a controlled environment where we understand how networking works, how servers work, how passwords work, how users are created, how we can block users, how we can retrieve passwords, before we can answer, okay, now we know all of we understand the workings, we can protect it. Main objective in cybersecurity, ultimate goal in cybersecurity is reducing risk of compromise. Compromise means anything affecting our CIA. Anything that drops the confidentiality of our data, makes our data less available. A customer is trying to sign into our application is not available. You don't ever want that, all right? Our application sends $500. The actual figure that should have been sent is $5,000. You don't ever want that, all right? So once our application says, this is letter from Mr. President of the United States, then it must be genuinely from the United States. You don't want to be a situation where it is found out that, no, that letter was fake, it was not sent by. So integrity must be maintained, availability of our system, and then confidentiality means only the right user that should have access to the data should have access. If our data gets into wrong hands, into unauthorized, gets to unauthorized user that should normally not even be on the network at all, then we have compromised our confidentiality. And all of these carry penalties. They can send us out of business, or they can attract penalty of up to 20 million euro. All right. So how do we reduce risk of compromise? By enforcing our CIA trial. Okay. All right. So when we say risk, what do we mean? So that we can begin to use these words. Okay. Let's give you a simple example of the term. So in the physical world, again, you have simply there's nothing to draw. So you leave the door of your room open, of your house open, in a place that is not so secure, so to speak. So once you have that situation like that, and then you have your door there. So this door is always open. Or maybe always closed, but never locked. So this presents a weakness to the security of your home. And then there is always this person out there that may, or maybe already actually waiting for that opportunity to take advantage of this weakness and be able to use this weakness to attack and come into your home and steal from your home. So this person that is waiting to take advantage of this weakness is called threat. In IT, we call this weakness vulnerability. Vulnerability. All right? So when you have a vulnerability, you identify a vulnerability, and then there is always threat. You don't have to go and look for a threat. There are, I mean, we're talking about internet and things that are exposed to the internet. So there are always threats, billions and trillions of threats waiting, always sniffing, even before you set up your infrastructure. So when you have threat and acting on vulnerability, then risk is introduced. So you introduce risk to each of these laptops, servers, switch, routers, even your data that you have on this network, they are subject to risk as long as, because there is always threat, as long as there is vulnerability, then you have exposed them to risk. So it means that once vulnerability becomes zero, then your risk is zero. But in practice, that is almost impossible. So the less your vulnerability, the more you reduce your vulnerability, the smaller your vulnerability, the weaknesses around your infrastructure, then the smaller your risk. All right. So in order to reduce your risk from being that high to being only this high, what do? You are not working on threat, you are majorly working on vulnerability. So you reduce the vulnerability all the way from here to there. And when you do that, you see, when you reduce the risk from that level to this level, you say you mitigate the risk. Right? All right. So we have threats as they relate to the infrastructure or the IT assets we are protecting. We have vulnerabilities around our network, around our data, around our server. All of them are vulnerable in their own ways, in their own respective ways. All right. And then they pose risk to our business and the way we do our everyday work. So what we want to do later on under risk management is to reduce that risk because it's not practical to completely eliminate it, reduce it to as low as possible. Keep mitigating the risk until it falls within the risk appetite of the organization. All right, questions? Question. So now you know what risk mitigation is, what vulnerability is, and then what threat is. All right, so how do we ensure confidentiality? All right. So confidentiality ensures that data is only viewable and accessible by authorized users. All right. One way to achieve that, in fact, the most common way to achieve that is to encrypt your data. Encrypt your data. Encryption simply means rather than keeping, so if I have a database and I have the names of all US citizens and their NI numbers, I'm not going to save the SSN number as plain text. I'm going to save the SSN number as jargons and maybe leave only the last 4 digits as plain text. Yes, Anna. Question?
A question.
Yeah.
So, like you say, how do you reduce the risk? So for here, do you have anything like policies that you create as a practice or no?
Yes, everything we do in cybersecurity, there are always policies, regulations that are governing us on how to do it.
Okay.
Is that your question?
Yeah, that was my question.
Yeah, we don't know anything. We don't know how to reduce it. We don't know how to scan vulnerability. We don't know what threat is. So there are always plenty of documentations are already inherited and prepared by the governance risk and compliance department. So we take those books, we take those documentations, and then we draw out what we should normally do now. It's like the book of knowledge, like the Bible of the industry, and there are many of them. We call them cybersecurity frameworks. We'll be looking at some of them later on. All right, ISO 27001, NIST cybersecurity framework, SOC 1, SOC 2, there are a number of them. All right, so these are the documentation that, and then we'll go online and download some of them. So we see that even if we do not know how to do, as long as we have the regulation that is governing us, yes, on how to do business within that industry. For example, if we're a payment card industry, we'll be following PCI DSS regulation on how to protect and do all of these things. Yeah, so we'll get there at some point. All right. Okay, so any more questions? Okay. So do you understand what we mean by confidentiality? And that encryption, yes, I was saying that encryption simply means we are not saving text plainly. We are converting maybe akin, we convert akin to, it doesn't make sense, right? So this is encrypted. This is the encrypted version of akin, encrypt. All right, so we save this in our database. So that in the event that this data gets into the wrong hands and they have access to our millions and millions of data, they cannot make sense of it, or at least as much as possible, to a large extent, they will not be able to make sense of. So we encrypt our data and then we save them. So that is one way to ensure confidentiality. Another way to ensure confidentiality, in other words, to ensure that only the right users are able to access and use your data, is through access control. Access control. So for every user in your organization, you are going to give access to what they have access to. By default, you create a user, whether that user is an in-house worker or a customer or some corporate clients. You create a user account for them, and then you give them access only to what you need them to have access to. Whatever you do not give them access to, they will not have access to. So that is, you control access to the services on the network. All right, so if I ask you now how many ways, you are going to say at least you know two. Encryption is one, access control is another, and these are the common ones. Steganography is simply hiding data inside another data. It's one method, but it's not commonly used. The first two are okay. All right, what about integrity? Are you sure I'm not going to? Are you still getting it? I just wanted us to complete this theory before we go ahead. Take a break before we go ahead and set up our lab. Are you still all getting it? Or maybe I should ask questions now to see who's not getting it.
Yeah, I'm actually following along and trying to, put the pieces to the puzzle that we are learning, and it's coming together.
Okay. Yeah, maybe I should take it slowly. Maybe I'm rushing. So, but yeah, I'm glad that.
No, we're
that's
following
okay.
you.
Yeah. Who was the other person that won me? So Brooke already spoke. Brooke is still following. Why is what? I don't even know. I don't know her name. What is the lady from Benin? Is she here? Yes, I'm following. Okay. Okay, so let's go. Okay, so yeah, let's quickly just explain the meaning of integrity and then we'll take it. So integrity means provides assurance that data has not been tampered with, has not been modified or corrupted through unauthorized or unintended changes. All right. So one way to do this is if I get a letter from President of the US and I really need to be sure, is this letter from the president? What I could do is I'll ask, as part of the security measure, as part of the practice to ensure that we are following the high integrity concerning this particular scenario, I'm going to do what they call hashing. So how does this work? This is how it works. So a typical scenario would be write the letter, okay, so that's the letter, write it. All right. Now hash this letter. When you hash the letter, that is, you give it to some application that will convert the whole of this letter into a simple text like 214 JID VIC 21. Converts that, you hash it. So you send the letter and the hash to the recipient. At this other end, I receive the letter, and then when I receive the letter, I also hash the letter. If I get exactly the same hash as you sent to me, then it means that this letter has not been tampered with. It's the same thing. But even if as little as a full stop has been added to the letter, this hash would change automatically. So instead of 214G, I will have something different. I could even have something entirely different from that. Maybe 11324 akin. So as long as we did not hash the same result, it means that the original letter is different from the received letter. So there's problem of integrity. All right. So this is how hashing works. All right. So you pass the data through some kind of algorithm to generate hash. And then when you send the data, I ask for the hash. I mean, this is not like everyday thing though. This is cases where maybe the Pentagon or is talking to China or something like that. So at that level, you need this kind of high level security, then you could do something like this. Otherwise, it's okay to just use unconsciously digital signature and audit logs. They provide non-repudiation. Digital signatures also provide integrity for files and email. So what does that mean? The term non-repudiation means something that cannot be denied. You do it and then it stays there. Non-repudiation prevents entity from denying that they took an action. So like we are going to see later, we are going to create scenarios where we deliberately cause havoc on our system, and then we'll go check the log to see who did what at what time. And then the log is going to tell us it was akin that logged into the system at 7:31 p.m. CST, and then he did this, it shows us everything. So that kind of report is non-repudiatory, non-repudiation. I cannot deny. It's just the system that has captured it. All right, so when we do digital signature, in other words, you use some email client like Gmail to send email. By itself, it assigns some digital signature. I'm not talking about you signing anything. It's just the nature of email. Email, part of the protocols that govern how emails are created and sent is that they attach the signature. So at the other end, that digital signature will confirm that this is not repudiated. It couldn't have been changed, couldn't have been altered. If the digital signature says is this, then it is this, then it becomes reliable. You can check, oh, it's the same thing. Oh, then you trust the integrity of that data. Yes, I understand that some of these things may not make very clear meaning until you do the practicals. But yeah, just know that. All right, so there is hatching, there is digital signature. And then lastly, you must do everything to ensure that in the event that you go out of business for 1 minute, for 1 hour, for 1 whole day, you have data to return to in order to come back to business. One way to do that is by taking regular backups, ensuring for a physical data center that your generators, your air conditioners, your heating system are working. And then, of course, you want to create what we call failovers so that in the event, like the example I gave earlier on about a regulation saying that you must always run 3 servers concurrently. All right, so that in the event that a data center fails and that server goes down, the other 2 servers can take the place of that failed server. That is called failover. Failover. Once one fails, another one takes over. All right. So that kind of situation is created so that you would have, or you guarantee high availability of your system, of your data, of your entire network infrastructure. It just depends on what, if you are making your entire system highly available, it may be more expensive, but wow, nothing will go down. But if you decide, okay, let me make only a part of the system highly, because of cost, let me make only the data highly available. If my servers go down, I can always go to cloud, spin up another server, but I need my data to connect. But whatever it is, if I ask you, what are the different ways to make to ensure that your data highly available, you definitely should tell me that I need to regularly take backup of my data, and I need to ensure that more than 1 copy of the data is running, so that in the event of failure, another one. Yeah.
Is that supposed to be the job of the cybersecurity person to make sure that maybe like you have like backups, like 3 different servers running, like you said, spinning up the servers? Are they the ones that do the spinning up of the server?
No, not necessarily. So cybersecurity is just part of a team. So in that team, we have operators, we have developers, we have DevOps engineers. So we have people whose job it is, really technical people, to spin up servers. All right. So the auditors, as part of cybersecurity, should just make sure that those people are doing what they ought to do, so that in the event that there is failure, we can continue in business. All right. But in your own case, as maybe in future as IAM security engineer, your work is, once this infrastructure are created, your own is to ensure that they are highly available. So while it's not your work to spin up the server to make sure they're highly available, it is your work to ensure that the people who should do the work do it, and then you always see that the backup is up. It's called compliance. So the regulations and the company policy says backup must be taken every 2 hours. Maybe it's not your work as a cybersecurity person to do it, but it's your work to check that the operators, the technical guys, that unit is in compliance with that regulation. So in that case, you drop what you call point to say, I detected that this is not working, and I forwarded this to the system admin to make sure. And then 2 hours later, I got a reply saying it's working now. And then I checked and I saw that we are back to 100% compliant. So that will be your homework.
I got a question.
Yeah.
So the other, like the fault tolerance and those other failover clusters, all of that, will we know what all that is?
Which one?
On availability, where it says, you said we would more work on the backups, like checking the backups, but is it a case where we would have to worry about any of these other ones, like the fault tolerance or load imbalancing and all that?
Yeah, they are all related. They are interrelated. It's just that first day of class, you will not be able to understand that. So I'll keep them for, I assume that you don't know what load balancing means. right now.
Okay.
Yeah, but I'll keep that explanation for later. But they are not too different. They are all interrelated. Fault tolerance is the concept of, for example, you have a server that runs that will run 2 fans on its power supply. So fault tolerance ensures that you have the 2 fans running there, so that in the event that one fan goes off, another fan takes its place, and instead of the entire server going down just because a simple fan of $3 failed, another fan can take its place. But it depends on where you are working, you know. They don't all apply together. This is for if you are working from home in cloud, this does not apply to you. But if you are working in a data center, and then once in a while you go to the server room to check physically what is happening, then this will apply to you. So we are general here. Yes, but the ones that are mostly applicable here now will be backup and failover. And then how this works is that when you go to the graphical environment, like you go to cloud now, which is too early to do, you are just going to see a dashboard that tells you this application should be 100% compliant, but it's only 98% compliant. And then you are going to scroll down, it's going to tell you what is not compliant. And then when you click, you are just going to see backup is more than 24 hours old, something like that. You just know they are not like difficult jobs. The theory of this job is harder than the practice. The practice is mostly click of a button once you understand the concept. But it's the explanation that is really task. So I don't know if that answers the question.
Yes, that helps.
Yeah. So as for the ones that I deliberately jumped, for example, load balancer, first day in training as an IT person, no, you are not going to understand that. Let's do some more practice, do something. Then you now see the place of load balancer later. Yes, somebody raised hand earlier.
Yes.
Somebody. Yeah.
I was having a question on the load balancing. Do we touch that one or we don't? We just monitor?
Do you set up a load balancer or you just monitor? Is that the question?
Right. Yeah. So I'm saying, do we just like ensure the security side of it? Because I know
yes, only the security side. Everything we do now is just the security side.
Okay.
None of these things that I've explained requires you to set them up. Even the setting up of the controlled environment we are going to use is only because we need that environment to practice. It's only because we need to practice in that environment. And there's no network guy now to go and call to say, come help us set us network. That's how we're learning it to do it by ourselves and then be able to practice in that environment. So at this level, at least in the first 1 month, you are expected to be able to secure, control the different infrastructure, not necessarily to set them all up. If you wanted to learn to set them up, then you'll be doing a different course like Cloud Solutions Architect. That is where you learn to set up load balancer, set up server, set up RDS, and so on and so forth. However, in the second month of training during Agile, you are going to learn to set up all of them. But in this first month of training, we don't really require you to know how to set them up, but to understand the concept of to understand their place and the necessity to secure them in order to secure your network and secure your data.
What about like the Splunk you mentioned earlier? Isn't that like the job of the cybersecurity person to set that one up?
Yes. No, we're going to set it up in class, so in case they need you to set it up. But Splunk is too big for one man to set up. Splunk is really, really big, and it's a team that will set it up. However, as cybersecurity, you should know how to use Splunk to monitor and to monitor your logs, basically. Yeah, you should know how to use Splunk because it's a tool for monitoring and remediating. This Splunk belongs. Oh, we remember what we called the SIEM earlier on? That's where this Splunk belongs. So as a cybersecurity person, you should know how to use SIEM and so on. Yes, you should be able to use. Well, in any case, we are going to set up Splunk anyway. Is this Splunk? Does it run on Windows or Linux? On both of them. Splunk runs on Windows, it runs on Linux. The one we'll set it up on Windows. Setting up Splunk is the last class of cybersecurity of this 1 month training. So it's still far away. Still very, very far. All right, guys. So let's take a break and then we'll come back and then we go to our virtual machines. We'll go and start setting up our virtual environment where we'll start to practice. We'll take a 15-minute break. All right, guys, welcome back. Okay. So yeah, let's talk about that later. 5 principles of following. Becoming too theoretical. Let's do something practical. Primary and to ensure. Yeah, already explained that. As professionals in the field of cybersecurity, our primary aim is to ensure integrity, confidentiality, and availability of information, while relying on established framework as comprehensive templates, as well as the principles that govern cybersecurity, allowing us to implement strategic measures that address specific cybersecurity challenges. All right, so our primary aim is to ensure CIA of our information while relying on established frameworks and comprehensive templates. Where's that coming from? From CGRC. All right, practical guide to set up your lab. You want to set up an on-prem enterprise network using Windows Server operating system, and then administer it to gain hands-on experience of cybersecurity concept in a controlled and safe environment. We'll be able to practice all of this. And by the way, I hope you can hear me.
Yes, okay.
Okay. So let's see if we can just find something. Let's go to LinkedIn. Oh, I don't want to sign in. No, I don't want to sign in. Let's try Indeed. Okay. So I don't want to sign in here. This is my cybersecurity system. So because of the sensitive nature of cybersecurity, I don't want to. Manager, internal audit, non-IT, hybrid. Okay. Software. Let's look for vulnerability analyst or management. I'm in Frisco. That could be anywhere actually. Cybersecurity specialist. All right. So what does this say? Hmm. $150 to $170. That must be. That's not entry level. Primary health growth. So bachelor's degree. Okay, so rewards now. Responsibilities. Where is it? Okay. Information security vulnerability management professional. Let's see what this one has. Vulnerability management here. Your impact. Develop, maintain, and run advanced reporting dashboard. Of course, we will do this. Evaluate and define functional requirements. Yes. Validate vulnerability. Of course. Okay. So senior vulnerability, entry level IT, GRC analyst, vulnerability assessment manager. Let's see what this one has. Responsibility, assess, evaluate, and make recommendation regarding. Qualified. Okay. These are all good. They are things that will cover vulnerability management, senior, cybersecurity analyst. Let's do IT security analyst or specialist. Entry-level IT security analyst. Perform schedule. 3 years. Strong knowledge of management. Strong technical application. CPIP, intrusion detection, knowledge of variety of infection. Yeah, we'll cover all of this, but I was hoping I'll find something that specifically talks about what we are about to do next, just to persuade you to pay attention and be able to learn to do it. But apparently I'm not finding it. But it's okay. Let me try cybersecurity analysis. Okay, let's try one more time. Yes, if you are raising your hand, you can go on and ask your question. Maintaining compliance obligation. Yes, always about maintaining compliance. Minimum of 5 to 7 years. That's it. Application security analysis. So this is specific to application security. Security analysis, open to remote. Let's see the prepare threat models for secure and recommended mitigation. Yeah. Choose it. Yeah. All of these are around the same things that would cover in the first month. So yes, you qualify for junior cybersecurity. Okay, let's say this junior. Junior. Experience in, yes, this is what I'm looking for. Experience remediating and patching Windows OS and software security. So I wanted something that just shows that you need knowledge of Windows operating system, and that's what we're about to do. So junior analyst, for how much is this one? Oh, wow, that's really junior. Senior security analyst, let's try it. Working out. All right, so not very many of them here are requiring that you have Windows experience, but it's a good foundation, whether they require it or not, so that they say, okay, you come into you are in cybersecurity, so where did you start from? Where's your background? Where did you enter IT? So this is a good place to say, I started IT as an enterprise Windows administrator, and then from there, I move on to become a cybersecurity person. Yes. Who raised their hand? I can take your question.
Oh, so I have two questions. One question. So after we finish the course, are all positions we are looking at entry positions? And that's question number one. Number two, I'm seeing some of them require you have a bachelor's. How do we go about that? Thank you.
Well, it's not a matter of whether it's entry position or senior position or anything like that. Just look at the job description like I'm doing, irrespective of what it's called here. And then if you feel that you qualify, you apply. So whether it is entry or senior or whatever position, just look at what they are looking for. You know, we saw some that require 7 to 10 years experience. So the idea is at the end of this 2 months training, you should have practiced enough to be able to claim up to 4 years experience. So if you have that confidence, then you watch out for positions that are requiring up to 4 years of experience. As for requiring a BSc, and if you don't have BSc, then you give it a try, but look for the ones that do not require cybersecurity analyst. Let's see. These are small positions. They shouldn't really require BSc. These are not big positions now. So let's see what this one has. Required skill, hands-on experience. So what this one saying about BSc? Yeah, this is what they should be like. Just hands-on experience with that. Hands-on experience should do, and then some certifications. 103, 155. Yes, I would say that just watch out for what you qualify for. That's the best answer. Watch out for what you qualify for. Occasionally you see, well, this fits, but it's just that not 100%. I miss this one, this two, this three. I'm still 90%, 80% fit. Let me give it a try. So whether they call it junior, it doesn't matter. So don't, if you go looking for only junior positions, then what if you don't find any? Does it mean that you do not qualify for the ones that do not carry junior? Yeah. Somebody else raised their hand. So have I taken care of these two questions? Yeah.
Oh yeah. So so this I don't know if it's related, but it's more like a general question. So I noticed that compared to let's say 5, 6, 7 years ago, the cybersecurity, workspace or market space or industry, I think a lot of people were not aware of it, or maybe they were aware, they were just skeptical. And I think that now a lot of people are realizing, okay, it's an easy way to life and all that. So the influx of people applying for the jobs. So, just per my, personal research or whatever, I'll just go casually, even though I don't know anything about the jobs. You could see that a job was posted 2 hours ago, and then you see like 200 applicants. And so, for people like us who are, now venturing into it and all that, I know you are not a magician. Ultimately, God determines everybody's life and everything. But what advice would you give to
Advise you to go beyond the basic that 200 people will qualify for and go to this level. Adjust security engineer, adjust IAM engineer. That
Okay.
entry barrier is a bit high. You raise the barrier. So the other one is low. That's why you have every time they can hire wanting to do. So if you come to this level of Azure cloud engineer, identity and access management engineer, yes, it should
Okay.
be fairly competitive. So I encourage you to do something technical that not anybody can do vulnerability test. All those things we're saying there, any 9-year-old can do it. But when it comes to deploy PAM on Windows, end-to-end, this is where you are separating the boys from the men, or the men from the boys. All right. So at this level now, you are not likely to see 200 applications. Yeah.
Yeah. Okay.
So learn something on top of the basics. And that is why even the technical area is good. If it's theory, just memorize and pass exam, fine. But when it comes to go to cloud and set up something, not everybody can easily want to train for that. People will be lazy at doing that. Yeah. Go all the way to the level where the entry is.
I
For
was
example,
thinking the same thing. I was like, yes, there's like a lot of people that apply for certain positions, but then I feel like, okay, if you gain the so I kind of worry about, because I see like that they need like a bachelor's degree or a master's degree for certain like positions. I'm kind of like, let me just learn now and worry about the rest later, because I feel like once I gain the knowledge that I should gain, then I will just kind of understand it more.
Yeah, that's right. So 3-year experience as an IDM engineer, this kind of roles, yeah. Yeah, I agree with that. So we just take it step by step. And then the next thing you should be looking at actually after you gain the necessary experience from the projects that you complete in class would be certification. So once you have certification, well, not like required, but if you are really worried that you want to separate yourself from the boys, and then more importantly, you're able to complete the projects and you're able to defend that, want to have it in your resume. I think for cybersecurity and most of these roles.
But at this level, do they train for whatever policies their company has, or do they expect you to come in and like?
Yeah, they expect you to have your certification or whatever you have claimed on your resume should have given you the general knowledge that they need. So their kind of training will not be the type that we'll have in here now, where you are sitting and I'm just dishing out everything. So it should be like, okay, since you already know how access and identity management works, this is how we implement it in our own organization. So they just give you access to their library, where you just read a few more documentations, and then maybe your team lead will just take you through a few hours of orientation. Yeah, that kind of training. Yeah, they certainly will tell you this is how we do things around here, but not like 1 month or several weeks of comprehensive training. No. Especially, again, if you are coming in at the level of 3 years experience, yeah, they can tolerate a lot of stuff and say, yeah, just, but if you are coming in with 5 years experience, they expect you to hit the ground running. So it just depends. If they are paying you 120, 150, they expect to get value as soon as you come. They are paying you 85, 90, where they can afford to. So it depends on the role. It's not the same for everybody and not the same for all organizations. So qualification, able to work. Yeah. So no, the reason I actually came here was to see the mention of a Windows Server operating system, but yeah, even though I wouldn't see many of that, it's still very relevant because as you will see in the resume, later on, you are going to say that this is where you came into IT from. So you must be first familiar with an enterprise organization and how it works before you can even understand what they are talking about here and then how these things work. All right, let me not take your time. You can always go back there at your. So let us set up our lab. To set up our lab, let's start. And then once we set up our lab, we are going to practice all of this. All right, let's go to, where do we start from? Install OS. So the first thing is we install Oracle VirtualBox. Install Oracle VirtualBox as our hypervisor on top of our operating system so that it can create virtualization for us. Then on top of that virtualization, we can now create as many virtual machines as our resources can take. So to download Oracle VirtualBox, we just take this link and then we click that. All right, so it opens here. Oracle VM VirtualBox is the hypervisor that we mentioned earlier. For me, I'm using Windows, so I'm going to click Windows installer. If you are using Mac, this is what you click. If you are using Solaris, that's what you click. So I'll click this for myself. It will download the Oracle VM VirtualBox. So that is downloading. All right. So that is downloaded.
Can you paste the link for us?
Are we? No, you are not doing this right now. You are just watching me and understanding how it is done. Then once the class is done, you would have the manual. You go to the manual and then you do it. You do exactly what I'm doing. So right now, I need your attention. Then you practice on your own. Okay. So that is downloaded. So if I go to my system now, I come here and I go to downloads folder where my files are downloaded. I see that Oracle VirtualBox has been downloaded. All right. So now that has been downloaded, I'm going to, the next thing I want to do is to download the server operating system that I'm going to put in the machine that I want to build, that I want to create. So server operating system. To do that, I hold my control and I click Microsoft evaluation copy for Windows Server. So I'm going to install this operating system in my server, and then I'll be able to manage my entire enterprise from there. All right, so let's download that. So to download Windows Server, I just complete this form. All right, so.
Should we download this now?
No, you are watching me and understanding what I'm doing now.
Okay.
Yeah.
Are we able to do this on the MacBook? I think you told me yes.
Yes, you saw where I just, you saw here where I downloaded.
Yes.
Yeah, so you click Mac instead of Windows. You click here.
Gotcha.
Yeah. All right, so let's go and do the installation now. Let me come back. Yes. So job role, any role, side, anyone. Job role, anything is okay. Manager, country code. All right. right. And then question, comment. All right, so download now. So this is downloading my server. Please select the Windows server that you want to download. Let's do English ISO 64-bit. So I'll click this, and that starts to download. It's downloading now. All right. So I have my Windows Server operating system downloading, and I have my virtual. Let me go and set up my virtual environment so I can set up my machine. So I come back to my downloads folder, and then I double click my virtual box to run it. I can minimize that. So this is my virtual box, Oracle virtual box, trying to install. So the first step was download. The next step, this step now is installing. Next, yes, and install. That's it. It's so simple to install. So we are installing the hypervisor on our operating system. And then on top of the hypervisor, we can now create our virtual machines. All right, finish. All right, so we have our virtual box, Oracle VM virtual box. All right, so in the time being, our Windows Server operating system is still downloading. But of course, I knew that would take some time, so I had one already downloaded from previous classes. So now let us set up our first virtual machine. So we come here and I say new, or I can come to file and say new machine. New machine, new. All right. So this machine I am creating, or let me call it a server, Windows Server. Windows Server. All right. And then I leave that folder as is. The ISO, the operating system I'll be loading into this machine, where am I taking it from? The one that I downloaded. So I'm going to look for it. And where did I download it to? So let me go look for download. Let me check here. Yes, it's right here. The one I downloaded before, even though the one we are doing today is just downloaded. So this is server evaluation copy. That is it. That's the one I already downloaded. All right. So I click that and I say open. So it takes that operating system. And it says, do you want me to install this for you without, asking me now, without me attending to it? I say, no, skip unattended installation. All right. And then I say, I've given the server a name. I've told it where to save the server. And I've given it the operating system to load into the server. And I say, I want to be attentive and to attend to this installation. And then I say next. All right. So this is my virtual machine. It's going to take the host. It's going to take resources for the deployment of my virtual machine from the host. Out of my 32 gig of host memory, how much do I want to take from there to assign to this virtual machine? This is going to be server. Let me take 15. Out of the 8 processors of the host, how much of that do I want to assign to my server? Maybe that. So you see why we call it host and guest or virtual machine. So we are taking resources from the host to assign to the guest machines. All right, so we take that. So if this works fine, then in your own case, you know that you will need to assign like 13, 14, 15 gig of RAM. So that's why I would normally recommend. If you have 16 gig total, it will still work, but if you have 32, it works better. All right, so I take that and I save it. All right, what about the storage? 50 gig of my storage should do. Is that okay? Let me just add a little more. So these are the 3 resources that I take from my host. I take CPU from my host, I take memory from my host, and I take storage from my host. And I assign these 3 resources to my virtual machine. All right, now my virtual machine has what it needs to be a complete computer. So I say finish. So we have created a virtual machine called Windows 7. All right, let us run it now. So to run our virtual machine, we'll say start the virtual machine. Start the virtual machine. So the virtual machine will start, and in the process of starting, it will discover, there's no operating system for me to start now. How do I start? Oh, there is a new one. Let me do the installation. So to start now, to install by itself the operating system. All right, so that's exactly what it's doing. It's loading, installing the operating system that we downloaded from Microsoft evaluation copy site. So the evaluation copy will allow you to use this free of charge for about 6 months or 3 months or so. By then, you should be done with training, and then you will not have to pay for it. So what are we doing here? We are trying to set up an enterprise network where we would be able to claim that we have done this before, we know what enterprise network is, we have used it, we have practiced with it, we have created user accounts and all of that, so that will not be lying in our resume, because we actually did. All right, let's watch closely and answer this question. So this will be in English, right? So we'll just say next. And then we'll say install the operating system in the machine, in the virtual machine. All right, so here, be careful here. We want to take the one that has Windows Server 2022 desktop experience. Make sure you take this, otherwise everything will go wrong. You'll not be able to have the experience that you need. So take the one that has desktop experience, and then say next. And by the way, this is explained in the note. And then you click accept license agreement. And then here, be careful. Don't say upgrade. Come here and say install new one. All right, and then you say next. And then to go on to do the installation for you. So in your own case, you'll be following this note step by step, just like we have it here. All right. So to create the virtual machine, you follow those steps. All right. So when you get to where it asks you what, select the Windows 2019. Could be 2019, 2022, it doesn't matter. All right. And then make sure you take the one that had desktop experience, like we just did. And then we accepted the terms and conditions. And then we select custom. Make sure that should be both, because it might forget. Select custom install. Windows Home. All right. So the next two we are waiting for now, type server password twice. So we're not there yet. It's still doing its installation. It's going to take a while. And then the next instruction, it should ask this for us to provide password. All right, so that's what we are following. And then after that, we sign into the virtual machine, and so on and so forth. All right, so Windows is installing. On every network, there is the server from where you administer the entire network. That's what we're installing now. And hereafter, we install 1 or maybe 2 clients from where, after we administer control on the server, we go to the client to test to see. We created a user on the server for the entire network. Is it working? So we'll go to the client to test, and then we'll say, yeah, it worked. Okay, let us stop the user from being able to access this, from being able to do this. Then we implement that on the server. Then we'll come back to the client and test. Oh, it worked. And like I said, it's only after it works that you're able to put it in your resume to be able to claim that I did it and it worked. All right. You can't just learn it in theory and claim that we know it. We must practice it before we can claim it. All right. So we'll continue to do the setup until everything is set up. And then once everything is set up, you must now complete the following exercises to be able to claim them in your resume. You create user accounts, and to be able to say, I can create and manage user accounts. All right. Group policy management, Active Directory auditing, access control that we talked about earlier on, role-based access control. To be able to complete all of them. Patch management, security, network security. Well, some of them may not, for some of them, you may not have the complete tool within a control environment, but as much as possible, we'll practice. Encryption that we talked about earlier on. Whether here or later, we'll do all of this. Imagine that you understand all of this and you're able to defend each of them because you have actually practiced them before at interview. That's what we're looking at. I mean, when we're looking at those job postings, this is what we're seeing there. They may have portrayed them differently, but this is what they were essentially saying you should be able to do. All right. So, yes, that's the work. We're going to take a while. All right. So, any question? All right. No questions, no contribution.
No, not at this time. We're just patiently waiting for the thing to fully.
Okay.
No.
Let me just let you focus. All right. So, yeah, somebody has something. After tonight's class, we'll get the soft copy manual, right? Yes, if you have paid. Once you make payment, I give you access to the manual, then I give you access to whatever you need access to. And then I'll be able to support you. When you are doing this on your own, it may not be as smooth as we are doing in class. You run into a problem, just take a screenshot of the screen with your mobile phone and paste in the group. And then I'll be able to tell you, this is what you are not doing right. And then once you get it right, then you can put it in your resume. Yeah, what about access control? Oh, you mean that is access control? Yes. I need to control access according to your payment policy, our payment policy, right? Yeah. Wow, it's going to be boring. Let's look for something to do. Let's go to pet. And then we'll come back there. Just waiting and doing nothing. Yeah. So, yeah, let me see. I got you. Control N. All right, so let's just get busy while we're waiting. So this is a network, right? Who can help me here? So if, Our users are coming to access our network through the... Hello, somebody trying to say something? Okay, all right. So our users are coming to access our network. Arnold, are you trying to say something? You are breaking. In fact, you can't even hear a word. It's just knowing that I'm hearing. But your hand is raised too. Hey, Arnold.
Oh, but when I talk, you can hear me, right?
Yeah, I hear you now clearly.
Oh no, this is a different person. This is
okay, that's Chris.
Yeah.
Looks like Arnold was trying to say something, but we didn't hear.
Yeah, I figured. Okay.
Okay, so let's check our machine. 86% down. Okay. Yes, so we're just trying to do some exercise. So our users are trying to connect over the internet to our application. So this is our network, our corporate network, where we run our application from. So who can tell me one or two things inside this our network? Anybody? Especially people who have not done IT before. Just mention one or two things that you will find inside this network. That are
Data and the app.
Sorry?
The servers.
Servers,
Yep.
okay.
Data.
Data, okay.
Application.
Application running inside our server, okay.
Web server.
Okay, you want to differentiate, you want to distinguish between application server and yeah, they are both. Let's just call this web server and app server. All right. Is there normally a gate here that would authenticate people to come in on it?
The internet gateway.
Yes, gateway.
Gateway.
All right.
Potentially around it, there will be a firewall.
Yes, correct. So firewall here, fire all around here. Beautiful. Exactly. This is the concept I just wanted to make sure you get. So yeah, that's fine. Yeah, data. That's correct. So all of this, especially the hardware part, they are what we call network infrastructure. So that's an infrastructure. This another infrastructure, infrastructure, and so on. When we say network infrastructure, or actually IT infrastructure, these are what we mean. Whereas the ones that are not like servers, they are just like application, you are running them, but you already have a server and they are running inside the server, not the server itself. In other words, you don't need to first of all set up a piece of equipment, whether virtually or physically, before you run them. They'll just run inside we call them service. So that's why sometimes when we say infrastructure, we also say service, we say application, just to say inside the infrastructure, you run a service. An example of service would be your application running inside the server. Server is infrastructure. Database is infrastructure because you need to set it up. Your gateway is infrastructure. You need to set it up and put it there, and so on and so forth. All right, you got it. Okay, so this is continuing. So which of these infrastructures are you securing as a security expert? Which of them?
Data.
All right. Who else? Somebody else try.
Network.
Okay. Another try.
User.
User, okay. Now tell me which one of them you are securing.
The application.
Okay, you are securing the application. Firewall. All right. Any other attempt? Any other try?
Endpoint.
Endpoint, in this case, you are determining what kind of endpoint are they able to use to access your network. Okay. What else? What exactly are you securing here amongst all of these things you've mentioned?
A gateway.
You are securing only the gateway. Yeah, the network layer, the network level, you are securing the gateway. Actually, you are securing all of them. All of them. So that's what I wanted to hear. That's it. So each of those answers was correct, but not full mark. Only one mark. Well, if you said all of them, then you are right. User, endpoint, the entire network, the application, the server. The server could also be called endpoint, and so on and so forth. So that's why we are learning a bit of all of them so that we're able to secure them. So the first thing we want to build now is a network that we can. We don't have a network, we cannot secure a network. Yeah.
I can get the number. My phone. I don't give my number to married men. Wow. Come on.
All right. All right. So we'll continue from wherever we stop because 20 minutes is not enough to complete this. We need at least 2 more lectures to complete this part of them. Maybe 1 more. Well, let's go on anyway. So getting ready. Okay, while that one is loading, let me see. I'm really not satisfied with what I saw from the job site earlier on. Let me see if I can find something. Let's go to Indeed again. Indeed. Okay, so let me look for the role of Windows Server Administrator. Windows Server Administrator. All right. All right, so this is what we're learning. Support virtualized MS Windows environment. That's what we're building, which includes operating system. So that's what we're building. And then after that, we're going to learn to manage Active Directories, domain servers. We're going to, what's this, lead engineering, of course. We talked about patches. You saw that in the task that you'll be accomplishing. So essentially, after this first 2 weeks of training, you should be able to apply to this role. But it doesn't mean that this role is available because, again, anybody can learn this and then, but just try. You never can tell. So we're going to cover all of this in the first 2 weeks of training so that you are, first of all, a Windows system administrator before you now build your ability to secure this environment on top of being an administrator. Design and perform computing environment, build out, installation, maintenance. Yeah, maybe not in detail, but at least you'll be able to, you know what troubleshooting is, because we are going to run into problems and we're going to be able to resolve them together. And from there, you learn troubleshooting skills, and then you can change. All right. This is the most important of everything Windows, Active Directory, and then domain controllers and domain servers. That's exactly what we are doing. At the end of the first 2 weeks, you'll be familiar with all of this. All right. So some positions will require that you are first of all familiar with this before you now learn how to secure it. All right. Yes, just like this one, requirement. All right. Even though that was what they wanted, on top of that, they now want you to know this on top of that. Okay. So let me just see one more. IT security specialist. We've seen that before, haven't we? Windows Server. This is just what I wanted them to mention. What sets you apart? So knowing Windows Server sets you apart from people who do not know Windows Server, even for the role of IT security specialist. All right, so I hope with that I've been able to convince you that what we are doing is not a waste of time, it's part of them. And this one is talking about virtualization. It's just that they are using a different software for virtualization, a different hypervisor. We are using hypervisor 2, they are using hypervisor 1. All right, enough of that. All right, let's go back to class. By now, class should be ready. So what do we have? Go back to my virtual environment. Okay, so we're at the point where it requires us to enter password. Please remember that once we want to enter, our username is administrator and our password is the ITAN 2024 hash. The ITAN 2024 hash. All right. The ITAN 2024 hash. The ITAN 20. Okay, that's good. So finish. All right. Now we are done with installation. Now let's log in. So to log in, we'll go to input, keyboard, Control-Alt-Delete. Our username is administrator and our password is the ITAN 2024 hash. And we'll press enter. Let's go to the note and make sure we do not forget our password. So if we come to our configuration here, Windows Server, we just signed in. We just went to input, keyboard, insert keyboard, and we just entered password. So that's where we are. And then I wanted to put here that our password is the ITAN 2024. No, we don't forget. All right, so let us say yes there. All right, so this is our server operating system. Try managing servers with Windows Admin Center. No, I don't want to. Okay, so that's fine. Our device is ready. All right, so let's continue with our configuration. The next thing we want to do now is maximize the VM display. All right, so to do that, we just insert the driver so that we're able to maximize it. Apart from maximizing, it gives our installation the ability to be real window. All right, let's do that. So we go to devices. All right, we say insert our CD. So we click that. So that is equivalent to opening the CD drive and putting our CD in there to install our drivers. All right. So now we go to, remember now, notice that we have two machines. This is my host machine menu, taskbar below, and this is the taskbar for my virtual machine. So right now, I'm working on the virtual machine, so I take that for the virtual machine. So I open my file explorer for the virtual machine, and I go to this PC, and I go to the CD that I just inserted. I open it, and here I take VBox Windows Additions. All right, so if I double click Windows Addition, it will load the drivers. Do you know what you mean by drivers? the additional software and applications that we need for Windows to operate optimally. They are not necessarily part of the basic Windows installation, but they come as extra, as addition. So that's what we're installing. We put in the CD and then, so this is the virtual environment equivalent of what we would have been doing if we had a physical system we have installed. So it is installing all of that, and it's now installed. It says, for everything we have installed to take effect, we must restart. We will reboot. So our virtual machine is restarting. It doesn't affect our host machine. All right, so that's what we just do. After rebooting, you may have to toggle the maximize icon at the top a couple of times for it to cover the screen. And then by that we'll complete the installation of our Windows Server operating system. And the next thing to do will now be to create a domain and promote our server to domain controller. That one we may not do today, but let's complete this. So now we have one virtual machine inside our host machine. So we have two separate machines. They are two separate. They are not connected. They are just independent machines. One completely separate from the other one. The virtual, otherwise called guest machine, and the host machine. All right, so we go to input, keyboard, control or delete, provide my password, the akin 2024 hash.
Quick question though. So
Yeah.
you see how when you you want to log into your computer or your desktop, you would Control Alt Delete whatever regular. Now with the virtual Windows, right? I notice every time you want to log in, you have to go to
Yes, if I do it on my laptop, it will affect my host machine.
Okay.
So my host machine is taking my keyboard. So in order to control to the host, I need to use this one.
Okay.
Yeah. Only for this one. But for regular typing, I'll go back to my keyboard. So like when I type my password, I use my regular keyboard. Yeah, just notice that. All right, so let us do something to cover the screen. So if we come here now and say, cover the whole screen. So you say view, and we say maybe full screen. No, not full screen. Just adjust window size, auto resize. So click that, and then no, it's not effective yet. Let's come back here and see auto resize. Yes, it's covering it. It's covering the whole screen. All right. So, I mean, we have a better feel of a real system now than when it was just occupying the center. All right, I guess this is where we'll stop today. Then we'll come back next time, and then we are going to learn how to use this security policy, security this, security that, and so on and so forth. All right, so we'll continue from here. Any questions? All right, so next class will be
when do we get this recording so that we can set this up on our own?
Yes, it will be available in 2 or 3 hours from now.
All right, thanks.
And then I'll share it in the group. Are you already a member of the group?
Yes.
Oh, okay. So I'll share the link in the group, and then you just click the link. And then... So next class will be Thursday. So Tuesdays and Thursdays. And then we'll continue from there. And so on and so forth. Yeah, that's it. So once we are done, once you are done with the system, to shut down this system, I mean, there are many ways. Even if you just come here and you close it, if you tell you want to shut down, you say power off the machine. So you power off and you say, okay. So the machine goes off. And then look at your virtual, your hypervisor, your Oracle virtual bus. So if you click that, all of the machines that we are going to have created and installed, they'll be listed here. Right now, we have only one. Next time, we are going to install one more, and then we'll have two. And then another time, three. Another time, we'll have as many virtual machines listed here as the resources of our host can allow. When I say the resources of our host, what do I mean? What are the resources? There are three of them. Can you name them?
CPU.
Correct. One, then two. CPU is one.
The memory.
Two, correct. Or the third one. Hmm? The third one is storage. So we have the CPU, the memory, and the storage. And you put those three in the chat. Yeah, they know CPU, memory, storage. These are the three. When we say system resources, this is the system resources. So how many virtual machines am I able to create for my host? It depends on, there's no answer to 3, 4, 5, 7, 10, no. It just depends on how many, the capacity of my system resources. All right, but good answer. So if you were taking notes, those are the short what you would attend, but you find them. All right, guys, we have 4 minutes to go. If you have questions, need any verification, we'll use those 4 minutes to take them. We cannot do anything completely new in 4 minutes.
Some of us, I mean, I'm not in the group, so I don't know how to get the link after this.
To be in the group, you have to make payment to join class. Who was that? So let's chat after class so that will tell me, you tell me what your plan is going forward. So if you feel this is something you can do, which I believe you can, but of course you should know yourself better than I know you, then we'll move to the next stage. And for 1 or 2 persons, you've already told me when they are paying. Yes, I can afford to share the link with you so that you can practice what we've done so far, so that by the time you make payment, you are not lacking. You are not lagging. But if you have not chatted and you have not made any promise or anything, then I will need to know what your stand. All right, so that's about it. And then, of course, I will also need your email address so I can. These materials are already in Google Drive. I'll just share the Google Drive with you. So alongside the manual, you find other materials there that will help you to assimilate everything we are doing. So share your email if you are in the group or privately, then I can share the resource. All right, thank you guys. It's been good having you all. I hope to see us all again in subsequent classes.
Thank you for the class.
Thank you very much, sir.
You're welcome, guys. All right, then. We'll see you on next. Bye, everyone. Mm.